Question 5, a 500 gram sphere. Now obviously we need to always remember to change this to kilograms, so that will be 0.5 kilograms, is 1,000 grams in a kilogram, is hung from an inextensible string. So this means that it can't be stretched. It's 1.25 meters long and is swung around to form a conical pendulum. The sphere moves in a circular horizontal path of radius 0.75 meters. Determine the tension in the spring. Now, we are wanting to work out the force that is being exerted by the string in this direction. That's the tension. Now, in doing this, we need to think about the forces that are being applied here. We know that there must be a force of gravity downwards, and I'm going to extend that line down, and that must be equal to the weight, which is equal to mg, which is equal to 0.5 kilograms times by, I'm going to use 10 here, meters per second squared for the acceleration due to gravity. So that's a force of 5 newtons down. Now, because the sphere over here is remaining horizontal, it's not accelerating in the vertical. So in the vertical sense, it is staying in a constant place. It is moving in the horizontal, but not in the vertical. There must be an equal and opposite force here in this direction here of also 5 newtons. And that must be applied by this string. This string must be applying it. So there's a force there, and the vertical component of that force is equal to 5 newtons. We can therefore work out the horizontal force. We can work out the horizontal force and also the tension just using some simple trigonometry. So what I'm going to do is I'm going to work out this angle over here, this angle theta. And let me really redraw this. We've got this situation here where this is 0.75, this is 1.25, and this is theta, this is 90 degrees. I can label this is going to be opposite hypotenuse. I have got that the sine of theta is equal to opposite over hypotenuse, so it's going to be 0.75 divided by 1.25. I can do that on the calculator to find my value for theta. So going here, I've got 0.75 divided by 1.25, enters, so I get my answer for that. Now I want to find the inverse sine to get my angle, so I push second function sine, then I do second function over here, and it brings me my answer, the 0.6, and I put it in and I get 36.86, so you can say 36.9. So my angle theta is equal to 36.9 degrees. That's this angle over here. Now I know that this is applying a force vertically upwards. The vertical force upwards is 5 newtons. So this force over here, the tension, if I redraw this now and put this, instead of having lengths, I now have forces. This angle over here, theta, is equal to 36.9. So again, I'll use a different color here. I'll use green. I've got, this is my adjacent, this is my hypotenuse, and this is my angle. So now I'm going to use the cos of 36.9 is equal to my adjacent, which is 5, divided by what I'm going to work out, my tension. Now we need to change the subject of the formula here, so I'm going to multiply both sides by t, and that will cancel my t, and then I'll divide both sides by cos of 36.9, 36 cos of 36.9, and I will get my t, my tension. So I see that I've already got here, when I look here, I've already got my value here. I'm actually going to have to close this off, so hopefully you will remember that. Actually, let me just rewrite that again. So I've got the cos of 36.9 is equal to my tension, this 5 newtons divided by tension. I hope you remember that. So tension is equal to 5 divided by the cos of 36.9. So let's put that in now to our formula. So we're going to get the cos. Now you see I've already got that value here. So I just pull in that, I put second function, and I pull in my answer. Now that's useful because I'm still keep working with a really accurate value. But in actual fact, let's just go back here and just clear that, because I actually wanted 5 divided by my second function, sorry, I'm getting this all wrong. 5 divided by the cos of my answer, and there we have it, 6.25. So the tension that I've got is 6.25 newtons. So it is a simple resolution of forces, knowing that because it is staying stationary in the vertical, we could say that there's a force of 5 newtons up, and then I could just resolve my vectors, just resolve my force vectors to find the tension.